Hello, is everybody on Zoom hearing us and seeing us? Welcome, everybody. This is such a big room for what I did expect not to be a very populated session. So I'm going to do the awkward thing and ask you if you're sitting way in the back, since it's just so few of us, maybe you want to come and take advantage of one of these awesome seats in the front. And if you do that, you get a prize. There's social media cards. If you come in the front, we'll be cozy and you'll have a present. Right, think about it. At any point, you can move forward and make me feel less like I'm lecturing and more like I'm talking to you. Welcome to the Software Management and Training in and for the Science Collaboration session. This session was pitched by the TVS Software Task Force, and it's designed for anybody that has to do with software development or management, or wants to have to do with software development or management for the science collaborations. And my name is Federica Bianco. I am Deputy Project Scientist for the SCs, but really today my hat is more of a science collaboration member. I'm a member of TVS. I'm also a member of ISSC, Informatics and Statistics Science Collaborations, and of the DESC. And I chair a task force within the Transients and Variable Star Science Collaboration, or DESC, which is the software task force. And that's mostly what I'm going to be talking to you about. And my co-chair is Riley Clark, and he's over there, and he will also talk to you about software training within the science collaborations. Okay, I don't have a schedule of the session on the slides, so I'm just going to tell you in words. I will have a few slides about the experience of TVS in managing TVS software. Most of the slides are not made by me, but by Rachel Street, but I'll get to that in a second. Heather Kelly will talk about the perspective of the desk on software management. Then we're going to talk about software training within the science collaboration and the programs that we have developed in the past couple of years. And then we're going to talk about the link frameworks, software sustainability and connections with the community for the link frameworks. Alex Mounts will talk to that. And then we're going to have a panel with a bunch of people. That's why I have a whole lot of chairs here. And those people will discuss what their concerns are about deploying, developing, and managing software for Rubin from the perspective of being in small software development groups, or at least mostly from that perspective. I do have reminders, primarily the reminder about the code of conduct. By now you know. Well, you should have always known that harassment and unprofessional conduct are not permitted or allowed. Hopefully you're familiar with that. If you do experience or witness any violations of the code of conduct, which you can find at this QR code, you can contact the code of conduct contacts, who are Rampal Jill, she's walking around here, John Franklin Crenshaw, and Agnes Fortes. You can all see them walking around, or you can contact them on Slack, or you can use the email that has been posted there. There have been cases of COVID reported, so wear a mask if you want to. It might be a good idea. I'm mostly wearing a mask when I'm indoors. I won't do that as I speak from here just because it muffles my voice, and it gets harder for you to understand me. You don't have to wear a mask if you don't want to, but be aware that there have been cases reported. And also, please respect the personal space of the other participants. We have stickers on our badge that says, speak to our level of comfort with physical contact in this new post and apparently not post-COVID world. So handshakes, fist bumps, prickly cactus, please don't get close to me. And we also have, some of us have social battery pins. If you see a person with the pin pushed all the way to the red, they might just be a little bit drained of social energy, and maybe this is not the best time to go talk to them. Maybe go talk to them when you see their pin sliding back to green. All right. I don't think there are any specific announcements for the participants, the virtual participants. The best and really only endorsed way to ask questions, to put your questions in writing, is to do that on the Slack channel of the session, which is the 4, 16 p.m., and software training and management. And if you put them on the chat, we might or might not see them, but certainly we will lose them after the session. So put them on Slack so we can keep them for posterity. And if we don't get to answer them live, we get to answer them on Slack. Also, mute yourself if you are not asking a question. If you do have a question that you want to ask it live, please raise your hand. It has been working really well in all the session. You can unmute yourself and ask the questions. And if you're a remote speaker, you know what to do. And I don't think I have anything else to say here. And I don't think I have any specific announcements. So here we go with the slides. So most of these slides have not been made by me. They've been made by Rachel Street, who was supposed to be at this meeting but couldn't make it. She's a much better software manager and software developer than I am. I'm very grateful for her slides, and I definitely will not do them justice. And also, Rachel Street and I have been co-chairs of TVS together for about 6 years. So we kind of like, in many things, we think and speak with a single brain. So imagine that I'm Rachel. Sorry. The remote is quite unhappy. Okay. So why do we have to manage software within the science collaboration? As you probably know, as of a few years ago, the way to access data rights for international community of Rubin has changed into what we call the in-kind program, where community can offer to contribute in-kinds to Rubin and get data rights for that. And a lot of those in-kinds are software. Of course, we had software packages being developed within the science collaborations even before that, because to do science, you need software, and the software might not exist to do your specific science. So we've always had a fraction of our community that was engaging in the development of software. Particularly for the in-kind, but maybe also generally for the software built within the science collaboration, we can think of two broad categories. One is directable software effort. That means from the point of view of in-kind communities, that means I will give you some FTEs, some people that can spend their time working on software that is helpful to your science collaboration. And you can tell me what this software is, and you can direct them to work on it. But we also have accepted non-directable software package. So software efforts. So people that say like, I know how to build this software and I think it will be useful for you. And so I'm going to propose that I will deliver the software to you. Either way, these projects have to be valuable to the science collaboration, and they have to be managed by the science collaboration. And the problem is that most people in the science collaboration are not software managers, do not have experience in software managing. And unlike astronomy has been thinking for most of its natural life, actually that does require specific skills and knowledge. So for the in-kind contribution specifically, there is a kind of like lifetime lifeline of the project. A team proposes the software, the science collaboration responds, yes, this is interesting to me, this is not. Then the Rubin project, Rubin accepts the software as an in-kind, and then there are requirements that the in-kind team has to meet with Rubin. They have to submit quarterly reports and demonstrate progress towards the goal, whereas the science collaboration had to give feedback to Rubin saying like, yes, indeed, the work that is being done is still in line with what we need and what we had thought of. There is kind of a missing link here, which is that this piece is not described. How the science collaboration interacts with the in-kind team has not been defined in the in-kind documents that Rubin has created, obviously, because it's not a Rubin responsibility. And that does require specific software management and expertise. And the science collaborations might not have them and certainly have limited personnel available to work on this. Okay. So there's a few things that have come to mind to Rachel and I and the software task force of TVS. A few things that we think are important. One thing is it's not really clear how to manage a software, because one of the things that is less clear of all of them is how to consider a software done for a science collaboration, especially for Rubin, because we're trying to shoot for like transformative science. So the software that we build as we spec it at the beginning might not really meet the requirement that we would need to meet to really advance the science when Rubin comes. This has been a tricky point for us because it's hard to design a roadmap for software, and it's hard to evaluate the software progress and give useful feedback if we don't understand exactly what are the goals. Some of the there's a list of things that might happen that might make it harder to design the outline of the software and the outline of the software development that are listed here. But in the interest of time, I won't go through all of them one by one, also because I keep going in the wrong direction with the slides. And also the people that typically write the software for the science collaboration, maybe a little less if they're in-kind contributors, but certainly if they are internal to the science collaboration, mostly are astronomers. And despite what we think, typically we're not really good at designing software and knowing the process. So we're trying to manage software that sometimes is completely not documented, for which there isn't in fact a plan. There might be a nebulous goal, and it's really treated like a science project instead of software development. And this is a problem for the software that gets developed, but it's really a problem for those who have to manage the software that is being developed. So we did think about what guidelines can we give to the people that are building software that will let us manage that software. And we have thought of some best practices. I don't know why these slides are very upset at me. We won't tell you what the best practices are, but we will tell you that it's really important to have requirements for the project, for the software development before you start writing. I think maybe this is our main lesson learned, that we were meeting with people that had already maybe drafts, so they already had code. Maybe they already had drafts of what the software was doing, but it wasn't clear what the software was required to do and how the software was designed to do what the software was required to do. So really, there is a tremendous value in understanding what are the requirements of the process. In the industry, you need to do that because you need to write down the requirements, because unless you meet the requirements, they won't pay you, especially if you're writing software as a contractor. But in science, it is more nebulous, and having these requirements is really the only way that enable us to evaluate the progress of the software being created. We do it by hand. Another thing that we have learned is that really it is much easier to understand the software that is being built if we're looking at prototypes first and not at complex realizations that aspire to be a final draft of the software from the very first time that you write it. Prototyping the software with the intention and the understanding that you will, in fact, throw away that code and replace it pretty much entirely really makes it much more beneficial, makes it much easier to understand what the requirements are. So this is something that you can do as you're writing the requirements, and makes it much easier for us to understand what the goals and the overall idea is. And in that, along those lines, you're going to aim for a minimum viable product first. You shouldn't shoot for a software that is too complex and too ambitious, but you should iterate. And the way in which you would do that within interacting with the science collaboration is maybe to map those iterations and map what intermediate goals your software can achieve and how they're valuable to the science collaboration, and then map the more ambitious goals and how they expand the usability or the user pool of your softwares. And of course, please write documentation, because documentation takes time to write, but it's vital to the sustainability of the software, to the communication of the software, the usability of the software. And when we manage software as science collaborations, we always try to make sure that the software that is being built is advantageous to most of the people in the science collaboration. And that's super tricky, because most people come to us and want to build a software that is very narrowly specific to the science that they want to do, because it makes sense for them. There is a piece of software that is needed for my science. And if I get to write it, then I get to do my science. And maybe I get data rights by writing the software, and then I get the data so I can do my science. It's a perfect loop from the perspective of the person that writes it. But our responsibility to Rubin, to the agencies, and really to our community is to make sure that we only spend time and invest resources in things that are useful to a large group of people. So writing documentation makes your software usable by more people. And I think this slide contains some of the content that we said. So let me go next. So how can the science collaboration help making all these happen? So we've done a few things. So I'm going to highlight three. We've written templates for documents for software documentation. We've organized training, and Riley and Alex Razin will speak to that. And we're trying to identify science collaboration members to partner with software developers. Let me speak primarily to the first two. So the TVS software task force was created partially precisely to do this, to create some documents that we could pass on to the people that write the software and help them create documentation that we could understand and then manage. So we've created two documents. We've actually been to IEEE classes to figure out how these documents are used and created. When this part was supported by a Heising Simons Foundation's fund that we had discretion on how to use. And we thought it was a great idea to train ourselves as software managers on what this documentation does and is needed for. So we created two documents, and they're in some cases fairly long and complex. You see here the first document that you should write, the software requirement and specification, and then the software design document, which was edited by Alex Razin, Marcus Hundermark, and Yannis Trapas for the science collaboration. So we started with templates of the IEEE, and we customized them to be really specific to Rubin. Things that we put in are, for example, how will you interact with the Rubin Science platform? Do you have a requirement to interact with the Rubin Science platform? And how do you design that piece of the interface, or that piece of the authentication, or that piece of the interaction? And you might think that this is unfair, because that means that the people that write software for TVS have additional requirement to the people that are in-kind contributions that write software for other science collaborations. But we think that this is really like save time by spending time on planning. And this really facilitates our own managing of these softwares. And then, of course, the other thing that we did, we organized a bunch of events. We've organized software workshops. I won't speak to this because we have a specific section of this session dedicated to that. But we've organized a bunch of software workshops. And the intent of these software workshops was for people to present their software concepts and sometimes their prototype to the entire TVS community. We've recorded them, we've made videos, we used Gather Town so we could create social time so that people could connect with software writer and could understand, is this software for me? Can it be adapted to be for me? The software writers could find user stories among the people that they were meeting at this workshop, could create forms more knowledgeably to ask them questions. We've organized 3 of these workshops, and over the course of that, we have collected a bunch of short videos of, something that we were asking is at what point in the process of developing your software is. And we plan on tracking this. We're a little behind on like really the aspects like, are we actually tracking what software is being developed and how it goes? But we plan on keep tracking all these software projects and at which step they are and how they develop. We plan on putting that on a website, but we haven't done that yet. But we do continue to host these workshops. And in the workshops, we have short video presentations by software writers. We have in excess of 30, I think, at this point, where they tell you what the software concept is, what point of development they are at, and how to use it and how to give them feedback. And I think that's basically the end of my presentation. So these are the things we've done. We would love really to hear what other science collaborations are doing. We think that managing the software, particularly the in-kind, because then we have a responsibility to the in-kind teams as well as to Rubin, has been not easy. And we really had to step up our knowledge and effort to be able to do that. And we'd love to hear what the other science collaborations are doing. So I feel like we're already running late. There's no clock anywhere here. Yeah. So why don't I not ask you to ask me questions and see if Heather is online, and maybe you can ask questions to either of us after this. Heather, are you online?
Yes, can you hear me okay?
Awesome. I'm gonna stop sharing my screen. Do you wanna share yours?
Sure, just give me 1 sec.
Screen.
Oh, there we go. Sorry, my connection is not perfect, but let's see. How do
Oh, we see you. We see your full screen, and we see that you're progressing towards the goal.
This is good.
Awesome. Let's see if I can remove.
Right, sorry.
You go ahead. There is something on our screen, but we're gonna work on removing it while you speak. Don't worry, it's only on the side of the screen. Oh,
Oh, it's probably me. It was
that was on
my,
your screen. Okay.
yeah,
Yeah.
sorry.
Okay, good. Go ahead,
Okay,
please.
so yeah, I'm Heather Kelly. I'm based at Slack. I'm one of the desk deputy operations managers and a computer infrastructure team member. Um, So my focus might be a little bit different than Federica's, but we'll get there. We'll see where we come out. So if you were at the science collaboration updates yesterday, you probably saw this diagram during the desk update. This is to give you a general idea of how desk is organized. Our basic organizational unit is a working group, which is dedicated to some aspect of desk science, like time domain or weak lensing and large scale structure computing, pixels to objects. And they're broadly organized into these either analysis working groups, technical working groups, or computing working groups. You might notice up over here, there's this desk management, which is led by our spokesperson team, and it also includes a coordinator team. So there's an analysis coordinator team, a technical coordinator team, and a computing coordinator team. And also mentioned in here are these operations management team, of which I'm a part, and the pipeline scientists and the computing infrastructure team, which I'll get to on the next slide. And all this is on our public website. Desk work is primarily organized into what we call desk projects with a big P. Projects are typically scientific investigations and or infrastructure development. And we typically try to scope it such that one desk project leads to one publication. Okay, so while much of desk development within desk is contributed by our collaboration members as well as our in-kind contributors, who are, as soon as they're in-kind contributors, they do become desk members. So I just keep that in mind. But specific development needs that are identified from our science plans are assigned to what we call our desk pipeline scientists and computing infrastructure team members. So the pipeline scientists tend to have, a cosmological background. So, are helping to build our simulation, processing, and analysis software. Our computer infrastructure team is, building the computing environment for desk, software stacks, setting up databases and services and things like that. So our pipeline scientists and computer infrastructure folks, over time are, developing work plans and working in coordination with the working group leads, what we call conveners, and our management team coordinators, whether that's the analysis coordinator team, technical or computing. And these folks submit quarterly reports and iterate on their work plans as they go along. But that said, all software development within DESC is really meant to be collaborative, between students, postdocs, staff at national labs, and these pipeline scientists and computer infrastructure folks. And so that really opens up the door to a lot of learning opportunities where you have people with a variety of software development experience. And I think we've seen the benefits of this already over the years where, we've had projects under development. People have come in and joined DESC as a student or a postdoc, gained a lot of experience in their efforts on that particular project. And then now we're seeing, they're either taking the lead on that particular project or moving on and leading and mentoring on some other projects. So I think we're really seeing that, like, that software development expertise pipeline is working for us, and that's really encouraging. So there's all this software around, and inevitably this leads to a need for a policy. So we have this desk software policy. It's went to effect on November 2021. There's a link there that's linked off of our public website, and the direct link is there. I mean, a lot of it is really focused on trying to encourage best practices rather than trying to define very strict, stringent rules that people need to adhere to. The thought has been to really try to cultivate a welcoming and nurturing environment within DESC. So I was preface all that with that statement. Part of the policy is spent defining different types of expected or anticipated desk software. So the here I'll really be focusing on the top two, the desk tools, which are really significant software packages meant to be used, in multiple analyses and maybe even outside of desk, and analysis software, which might be a single analysis for a single paper. And then then there's other things like paper support scripts and external software and that kind of stuff. And I think the expectation with that is to highlight that different types of software may have varying amounts of scrutiny required as far as how much validation and testing you do, and the amount of documentation, and whether or not there's long-term maintenance required. I'll just flash this up real quick. So this is literally from the software policy for DESC. And basically the idea is that we have these guiding principles, and I won't read them all, but maybe I'll highlight a couple. And I think in particular visibility, we want to make sure that people who are contributing code also tend to be have a science life as well. And we want to make sure that their contributions are visible and that they're fully recognized. And also trust, that we anticipate, everyone is trying to work toward accurate scientific analyses, producing good software, and we're all trying to learn as we go along. All right. So if you ever take the time to read this desk software policy, you'll notice that in there it references this other document, our desk coding guidelines, which basically were written to provide this introductory training and a set of pointers for effective software development. It really does go much more into the details of things, of how, maybe coding style recommendations and how to set up a code review. We even have a comprehensive code review of an API and the general design of some software package. Again, not requirements, but really meant as a resource to help people, especially those who are, maybe don't feel as confident in their coding skills, to become familiar with things like using Git and GitHub and that kind of thing. And speaking of which, we do have a GitHub organization. So I hesitate to say this, but I think most, if not all, of our software is public. I mean, we don't require that from the get-go. There is an expectation that under development of a desk tool that, the whole collaboration at least has read access. And by the time of internal review for other types of software, everything would be at least read accessible. All right, so I was just going to highlight a couple of little things that come out of either the software policy or our desk coding guidelines. So one of the things that the software policy does require is that when a desk paper reaches internal review, at that point, there needs to be a software summary document. Basically, it's going to list all of the software that was used to produce that publication, what code validation and testing was done, the versions of any external dependencies that the software is relying upon. I mean, basically, it's having an eye toward reproducibility, not only like immediately, but also, years from now, if that becomes necessary, or if there's an interest in that particular piece of software in the future. So, I mean, I think that's kind of the thrust behind that. There's a variety of recommendations, but I would just highlight a few of them. Again, while it's not like a strict rule, certainly, we're encouraging, software should be continuously reviewed, documented, and tested at an appropriate level during development. Where appropriate level is left to those developing the software. And a higher expectation would be applied toward desk tools, which are again meant to be these applied for multiple analyses and have a long life. We do encourage open source licensing, at least by the time of paper publication, if not sooner. Again, not a requirement, but I think as a collaboration, we felt it was important to promote open source, particularly for science software. Semantic versioning, we promote continuous integration. So we have our GitHub, not, fairly easily can utilize our GitHub actions. I didn't link it here, but we do have a document that I can add later that provides some outline of using continuous integration within DESC. And we promote using branches and pull requests and Git. We're encouraging our less experienced software developers to help out with code reviews because it is a very good way to learn. If you have people that are writing good code, and then you have someone who's trying to learn a little bit, it is a good practice, even if it can be a little daunting at first. We do encourage making software ultimately installable either from PyPy or CondaForge, because we're developing software, but ultimately we also have to be able to install it and use it, and to avoid pinning to any particular version of a dependency like NumPy or something like that. Right, so early on, DESC recognized that we're going to have members in our collaboration with varying levels of experience and comfort with developing and using software. So I think efforts were made early on to help lower that bar through tutorials. So I'll just point this out. I think we have a YouTube video from Phil Marshall from 2016 introducing GitHub, which I don't think, I think if you search for it, you can still find it, which it's actually still fairly relevant if you need to get introduced to Git. That was an entertaining way to do it. But starting as early as 2015, we started having these LSST dark energy schools. And there's a link there. Again, this is off of our public website. And this is a great resource. These are held biannually during each of our collaboration meetings during the year. And they cover a wide range of obviously scientific topics, but also there's been some emphasis on software development, including unit testing and things like that. So I would invite you to peek at that link. There's recordings and slides since 2015. So that's a really nice resource. We do have annual sprint weeks where we basically try to, or at least some subset of us try to drop everything and focus on a set of sprints to work together collaboratively during a week to try to push forward development on a variety of different things. We do try, and I think we've succeeded pretty well, to have at least some subset of sprints that are purposely trying to attract new members of DESC or people who are not quite sure yet how they want to contribute. So that way it's a welcoming and maybe an easier path to just get your feet wet and get it working together. Let's see. So I guess I'll also point out, NERSC is our primary compute facility, not our only one, but one of our primary ones. So we do maintain Conda environments and Jupyter kernels at NERSC that include desk developed software. So this provides a way for our members who may not be developing to actually use the software as soon as possible. NERSC itself also offers training on using its resources, which is also handy because we have members who have not used an HPC facility before, or may not really have a lot of experience using Slurm or MPI or things like that. So that training resource is something we point people to. We have Slack, and we encourage people to use that to reach out for help. To say most of our software projects do use Read the Docs to post their documentation and provide tutorial notebooks to help people get started. And I think our group is pretty good about, if someone in a working group is using code and they have questions, they do reach out. They try to update documentation as they go along, which is always encouraging. And I'll just flash this slide up. So this is not an exhaustive list, but this is some of the DESC tools that are being developed within DESC. And you can click on those and I'll just show you bring you to the GitHub repo, and most of those, if not all, have links to their documentation and tutorials. And I think I'll just stop there.
Thank you so much. Let's thank Heather, please. So we're running a bit behind, but I want to allow at least one question primarily to Heather because I'm here and you can see me around and ask me questions later. So does anybody have a question for Heather? Yes, Tom.
Okay, I have to pick one. I guess the most pressing one, I suppose, would be funding. To listening to those two talks, you mentioned a lot about it takes extra time to do things with software, but also both of your talks mentioned you had Heising Simons funding and DESC has NERSC funding. How do we get every funding agency to accept this? Because if you're an astrophysicist, you just take a 2-year postdoc or 3-year postdoc, whatever, and you're not going to convince them that you need these 6 extra months to write the software properly.
Let me burst your bubble right away because the Heising Simons funding has been used and finished. So we currently do not have funding. So everything.
But it was really good.
Yeah, it was
good
transformational.
Yeah.
And a large fraction of it went towards software-related activities.
So how do you convince the next funding agency to give you the same flexibility?
Well, trust me, if I knew, I would have funding.
Yeah.
But I appreciate the question. Heather, do you want to add anything about funding?
Yeah, I wish I could. I mean, I think we were very fortunate in that the only funding we really have is for the supporting of the pipeline scientists and the computing infrastructure folks. It is limited. I mean, there is a point where we are going to not have that available anymore. And as far as NERSC, I mean, it's not really, it's granted to us, but it's not something that it's not something we actually have funds for. It's not real money. It's something that DOE gives us an allocation, and we're very fortunate to have it. But it's not actual funds. But yeah, I actually understand. I mean, it's very difficult to have. Yeah, I mean, it's very difficult.
It was a rhetorical question, and I guess for transparency, I'm funded through the LSST UK in-kind contribution and have had many years of dedicated 100% FTE time to write software. So I'm also quite fortunate in that regard. I just thought
I very much appreciate that you brought it up because this really needs to be discussed.
It's a rhetorical question more than anything. Yeah.
Let's move on with the program, and we have Riley and Alex Razen speaking. Alex, are you there online?
Yes, I am. Can you hear me?
Yeah, we can hear you, Alex. Thanks.
Okay, good.
Okay, hey everyone. I'm Riley Clark, and I'm a member of the TVS Software Task Force, and I'm teaming up with Alex today to give a report on a community-led software training workshop that we call the Intermediate Python for Astronomical Software Development that was just run earlier this month with support from the Heising Simons Foundation through the Discovery Alliance. And just to give a little bit of background, the idea for this community-led workshop originated from back in 2022 when TVS through the Software Sustainability Institute ran a training workshop within TVS where professional software engineers were brought on to train astronomers how to write software projects in the same way that engineers do. And fortunately, the materials that were used for these lessons were open source and free for anyone to modify in any way they see fit. So our idea was that we could take these materials and edit them slightly and kind of orient them more towards to be more useful for the astronomy community. Because the training was extremely useful, I think, for all the reasons that Fed summarized at the beginning. But there is a difference between developing software for astronomy and developing software in industry. And so we developed a curriculum that took place over 4 days, where on the first day we talked about setting up environments for collaborative code development, some basic tutorials on using Git and GitHub, style conventions, using virtual environments. And then day 2 involved ensuring correctness of software at scale, developing unit tests, using GitHub issues and continuous integration through GitHub Actions. And then the third day involved exploring different programming paradigms, functional versus object-oriented programming. And then the last day was a more collaborative day of the workshop, where we got into breakout rooms and did small code reviews and submitted pull requests to each other's repos. So I just want to give a quick overview about the respondents, or the participants of this workshop. So we had around 41 participants from 38 institutions all around the world of various career stages, but mostly postdocs and PhD students. And we had representation from 5 different science collaborations: STARS Milky Way, ISSC, AGNSC, DESC, and the TVS. And then we got, of those 41 participants, I think 11 responded to the post-workshop survey, where we wanted to get a sense of how people felt about the materials. And one of those questions was, this workshop was mostly a self-learning mode, where the participants were free for the time period to follow the materials. And we had volunteer instructors nearby to help if any issues arose, but for most part, the learning was self-directed. And I think, and it seemed like from the responses that most people were comfortable with that learning mode, but there were a couple that suggested that maybe it'd be better to have a traditional kind of lecture style demo that led into a self-learning mode. And each day was, there was 4 hours per day set for this. And most people stayed till the end, or almost to the end, but some people would leave after an hour or two and return to the materials later. And then we wanted to ask on each day whether or not people finished going through the materials completely. And I think on day 1, and especially on day 1, yeah, most people finished mastering the materials in day 1. But then in the following days, some people came back and finished materials after the session. And so we're still able to asynchronously engage with the workshop materials. And then we asked people how did you find the usefulness of the workshop per day? And I think people found the first 2 days really useful, the best practices and GitHub Actions, but perhaps that maybe kind of declined towards the end of the workshop. And then we got some great feedback on what kind of topics of the workshop that people really liked. People liked the collaborative exercises, people with making GitHub issues and pull requests, the self-paced nature. And then as far as some of the aspects that people maybe didn't like, small oversight was that we scheduled the workshop on the 4th of July, and we had a lot of US participants. So that made it a little difficult for people to participate for the whole duration of the workshop. But yeah, I think that's my overview of the survey responses. So I think now I'll go ahead and turn it over to Alex.
Thank you, Riley. I believe you should stop sharing your screen in order for me to. Yep, thank you. Okay. Let me share my screen. 1 second. Okay, great. So thank you, Riley, for the great overview of our last workshop. And I cannot quite, I think I glimpsed the number of people in the room, but I do not know how many of you have been familiar with this, have heard maybe some of our announcement of these workshops. But I had a look at the list of the people who are connected via Zoom, and I see that not many familiar surnames are there. So I suppose not all of you are aware of what we were doing. So as Riley already said, our InterPython initiative started 2 years ago after Simons Foundation funded a carpentries workshop for the TVS community, which was a great success. But we, after attending this workshop, a number of us realized that we can make it better, suited for the astronomical purposes. So we decided, okay, let's adapt some stuff. Let's drop PyCharm, for example, and switch to Jupyter Lab, because most of the astronomers use Jupyter Lab for better or worse. Oh, Jupyter Notebook, but we switched to Jupyter Lab for a more advanced version. So since then, we got a grant for honorariums for the developers and instructors of the workshops. And we organized 2 workshops. The first one was a test run for the TVS members, and we had about 20 registered participants. And the second one that indeed happened this month had about 40 registered participants from all over LSST. And in general, so it was in the format, it was pretty close to the original carpentries workshop. So it was mostly self-learning with some interactive sessions, and with us, the instructors, being available for help for the participants. And it was evaluated that it should take 4 days, each day 1 4-hour session. And it was required for the participants to fully grasp the materials, to finish the materials of the previous day in order to actually move on with the next day. So it wasn't like independent topics. It was a single software project that we are developing across through the days. And by developing this, you are getting a crash course on everything that is good against everything that is evil. So best practices on coding, coding style, commenting your code, documenting your code, using Git and GitHub in collaborative and individual way, programming paradigms, how to publish your code, how to turn it into a package. So stuff like this, like everything that you probably heard in some talks about how to produce a good software, it is at least touched in this curriculum. And it, in my opinion, it was pretty successful because we managed to adapt this curriculum to make it better suited for the astronomy. The self-learning mode is pretty convenient because it allows people from different time zones to connect, to drop out if they have, I mean, if it's 2 p.m. Or 2 a.m. Where they are, to come back after some meetings, for example. So it was flexible, it had strong curriculum, and in general, it was a great, successful experiment. But there were also downsides. First of all, the general survival rate by the end of the workshops isn't so great. If we had from 20 to 40 registered participants, maybe like half of them showed up by the third day, maybe sometimes slightly more. And by the last day, we had only a few participants left. Probably, well, first of all, it is pretty hard to fit in your brain a bunch of very different topics in only a few days. It is objectively hard. I mean, when I attended the first carpentries workshop, I was really excited about it. It's a great workshop, but it is hard to actually fit it all in your brain. Secondly, people probably are missing some sessions and then not coming back because they feel like they need to catch up with the materials, and then some other applications are coming up. You know how it is, so they never come back. And then there is a fact that not all topics are interesting for all the participants. So among the answers in the post-workshop survey, we had people who were very excited about collaborative sessions and collaborative exercises with GitHub. And there were people who were like, I don't have much use of it. There were people who were really interested in learning about how software requirements are produced and how they influence the process of software design. And then there were people who were writing like, I don't need writing a software requirement document for my scripts. Why would I need that? Which makes sense. We are all different. We work in different ways. So obviously, fitting it all in one workshop, well, it is natural that some people will get bored in certain places. But there is a reason why this workshop was made this way. So this is what I want to share with you also. This is a survey on the coding tools and best practices in the LSST community. This survey was organized between our first and second workshops in April this year. We had about 45 respondents who were really not representative of our community, because as retrospectively we realized, very few people read Announce Everyone channel on Slack. So when we were announcing the second InterPython workshop, we realized that what we need to do is to add ourselves to the channel of each science collaboration and duplicate the announcement, whatever, 8 times. I mean, I apologize for spam. If some of you are signed up for several channels, you might have gotten the same announcement numerous times, but this is the only way to actually reach everyone. This is crazy how few registrations we got after publishing the announcement, Announce Everyone, and how many have come after we published it in every channel that there is essentially. So this survey was done via Announce Everyone on Slack and via TVS channel on Slack, meaning that most of our respondees were from the TVS, and there was also a disbalance in terms of what career stage was these participants on. So most answers came from permanent position people and slightly less from postdocs and from PhD students, which is not exactly representative of the community of LSST, even Slack, not speaking about LSST in general. Even. But still, getting 45 answers was pretty enlightening, in a sense that we were asking, yes?
I don't want to interrupt your flow. Just be aware of time, please. We're running, everybody ran a bit long.
Okay, I'm gonna be as quick as possible. So we were asking about what people are using in their work, and turned out that most astronomers code often, reasonable. Most astronomers use Git and GitHub repositories also often, but almost like a huge part of the respondents never write unit tests, never write software documentation, never write any kinds of software requirements, never use tools like linters, so for checking code style, and approximately half of the respondents never write or almost never write software collaboratively, meaning that like half of the respondents write their code alone and don't use stuff for ensuring the high quality and reliability of their code, like unit testing and documentation, linters, and so on. And it wasn't very surprising to me, because I am a very typical, I am from this group as well. I rarely write code collaboratively, and there is no external incentive for me to do unit testing, to do software documentation and stuff like this. Actually, I have to push my collaborators quite often, even to use GitHub for sharing code and for keeping track of our work. And this is an issue, because it's a great thing when you can learn good practices of software development by osmosis in a well-established collaboration, but most of us don't have this opportunity. And the only way we can ensure that people are actually learning this, because it might be okay not to use this stuff and not to use these tools if you are writing small scripts. Sooner or later, you're moving to bigger projects. And then when this is happening, unless you have a habit of writing good Git commits or writing decent unit tests, you will not develop this habit out of nowhere. It's like cleaning your teeth. You have to learn it from being as young as possible. And this is the reason why doing these workshops that are covering all the best practices topics, it is really important, because we have to introduce it to our students and to our PhD students early. It's too late when people are already well into their postdoc positions. It is already hard to relearn in this way. But obviously, if the survival rate by the end of the workshop isn't that high, it's the format that doesn't work this well. For this reason, we are thinking about slightly switching things, and we think about organizing a set of single-day workshops dedicated to single topics, and to try to organize these workshops more frequently without advertising them like 2 months in advance, but advertising them maybe a couple of weeks in advance, so that people already knew their schedule and could plan their time, like, okay, this one single day I can dedicate to this training. And there is a huge range of topics that we would like to cover and expand. Some of these topics were already covered in our InterPython workshops, but some were requested in the feedback forums or suggested by the developers when we were working on our original workshops. However, this kind of organization it requires a lot of also management and initiative. And I would say that we have about 8 or 9 regular maintainers of our workshops. And none of us are actually software developers. So this is very much a grassroots initiative. We are typical astronomers who have learned this stuff by their own, sometimes didn't learn, but are learning when developing the materials. So in order to make this possible, we would really need a coordination between different science collaboration and help from software developers who are more professional in this sense.
Alex?
Yes.
On that note, and seeing that you're bringing up the issue of funding and honorariums and
Yes.
support, I'm gonna ask you if you can, if I can interrupt you here and move on. But I really appreciate that you put out the 3 challenges here that are obviously core to all the things that we are saying: coordination, professional support, and honorariums and funding.
Totally. This is the last slide.
Okay, thank you.
Yeah, thank you.
Let's thank Alex. And we don't have time for questions now, but let's see if we have questions that come up in the panel. I do want to leave enough time for the panel. While I ask my panelists to come and sit here or unmute themselves if they are online, can you please, if anybody has a question for Alex Razim, Alex Miles, or Riley, we can ask that while we're doing the arrangements. I don't see any hands up. Perhaps I had discouraged you too intensely from asking questions. I wanted to get maybe we don't need to screen share. Stop share. Yes. Okay. And do we have our online panelists? Can you unmute and confirm to me that you're there?
Yes, thank you very much.
Hello, Marina. And you were the only one online, I think. Yes, because I count 5 here. Yes.
Okay.
All right. So I gave you all a short prompt. We have about 15 minutes and a little bit more than 15 minutes for this Fast and Furious panel. The prompt that I gave you is, what is your single most concerning concern about software development from the perspective of small groups for Rubin, based on whatever you said and whatever your perspective is. So maybe we can start with Marina, who's online. So do you want to say, what is your perspective, i.e. what is your role and the role that you're speaking in, and what is your main concern?
Yeah, thank you very much. It is really a great pleasure to be a panelist of such an interesting discussion. So I came from the in-kind team from Serbia, really small team. We have like 10 people, maybe a little more than 10, and we are software developer in-kind contribution team. Now I'm based in the La Serena, and I'm currently working also as the commissioning scientist at Rubin. So regarding my concerns in the small team software development from the in-kind contribution for Rubin, I would definitely want to emphasize that maybe the limited manpower is actually my really big concern because that actually means that all the people in the team had to balance some multiple roles in the team, from doing the code, from writing the code, developing, through the testing, through the writing the documentation. And all of us actually experience, of course, the project manager role, especially in the small teams. And this can actually really be challenging because we are on a couple of fields in our work. And of course, this will also slower all of the development cycles from the development to deploying the software. Other concerns that I actually have, and Alex Resim actually talked about that, is actually the lack of expertise. So none of us is a software developer, none of us is a programmer. So we are all astronomers, really enthusiastic astronomers, I would say. And we are all like learning through the whole process. And I know that I've been in the in-kind contribution team for a little over a year. And the first project I was working on was a machine learning project, and I had never worked in the machine learning. I didn't know what the machine learning is, what the deep learning is, and my task was to actually build a software based on the machine learning. So a lot of things I had to learn throughout the process, and that actually I lost a lot of time during this process. So I would say that those are actually my main concerns, like limited manpower, limited expertise, which
Thank
actually
you, Marina.
slowers the development. Yeah, thank you very much.
Thank you so much, and thank you for joining us remotely. You got a pass because you were the first speaker, so you got 2 concerns. Everybody else, please
Oh
keep
yeah,
it to
thank
1 or we
you.
run out of time. We're gonna go ping pong,
Sorry.
so Vincenzo, then Katerina. Go, Vincenzo.
Hello, everyone. Well, I think that the concerns that Marina was. Oh, yes, I'm Vincenzo. I'm a PhD student in Napoli, in Italy, and I'm part of the TVS Science Collaboration, but also EGN and DESC. So I think the main concerns are what Marina was raising. So first of all, manpower for small groups that want to do something. But at least for my perspective, as a student that was starting the PhD, you really don't have in mind that you are preparing something that is to be released to other people at the very beginning. And so you start writing a code, and then at a certain point you think, okay, but this code might be useful also for other people. And you start to think about preparing this code and putting it somewhere so that people can use. And to do that later is more difficult than to start with an idea in mind. And one of the easiest thing is, for instance, that you need to prepare an environment with all the requirements that allow your code to be tested and run by other people. And so, for instance, I remember that when I started a project that was within DESC, and I was using the time domain environment in DESC, everything was easier after I understood that I needed to run that environment, because I was not in the position needing to downloading all the software and all the pip install thing to make things work. And so this is also related to a question that I would have liked to ask before to both you and Nether. All the software that are going to be developed, both as in-kind contributions or as contributions for smaller group, how are they going to be delivered and integrated into, for instance, the RSP for later uses? Because it is not such an easy thing to have all the environments ready and set up with the proper version if you need to use it. So this is one of another concern, which is not.
So everybody's violating the rules.
Yeah. Thank you.
All right. May I suggest that if we continue to talk about it, we refer to it as person power, a little bit less gender bias than men power.
Hello, my name is Katarzyna Kruszyńska. I am a postdoc at Las Cumbres Observatory working with Rachel Street. I am a software developer for like different tools that we use in our small team. But I'm primarily an astronomer, and my main concern with developing software for Rubin is the sheer amount of data we will have to process well and fast. And that's it. I don't know how to solve it. I don't work in big data. I am just terrified, and yes.
Hey, Wes Fraser, Herzberg Astronomy and Astrophysics, and I like the solar system. My main concern in general software development now is the style guide. Find out this before you start your project, before you get too deep, find out what the style guide is. If you can't find the style guide, ask for the style guide. And if they tell you there isn't one, call them liars, because programmers are just as opinionated as astronomers. There is always a style guide, and it sucks when you spend a year developing something to have the entire thing rejected because you decided to use a dictionary or pandas or some other iterator than the master developer wanted you to use.
I'm Alejandra Muñoz Rancibia. I'm a postdoc in Chile. I'm part of the LSST broker. I'm an astronomer, but work closely with the infrastructure team that develops the tools in the LSST broker. And my main concern is the communication between the size of a software, let's say the people that develop and the potential users or actual users that you have in mind. And I express that concern thinking also in the success cases that we have had where we have humans testing our code and communicating a lot with very frequent meetings to discuss the thing. It's not only like giving the requirements and then testing. I think that communicating a lot helps to, especially to minimize misunderstandings. But when wanting to point to science collaborations that are so big, I don't know what is the best way to do it, because you can provide a survey, a Google form, but it's hard to reach the people. I'm also part of the users committee of Rubin, and for us it was successful to reach the people one by one. Maybe that would be a nice approach, but that also takes time, and takes humans to do that too.
Hi.
Hello.
Okay. Hi, I'm Orion. I work, I'm part of DM. I work on a lot of issues related to data release processing, but I actually have a science background, like most people in DM. And when I was first asked this question, my first thought was like, oh, duplication of effort is going to be a problem, especially with tiny groups. But I've been kind of mulling it over, and I realized that the broader issue here in my mind is that when we develop software projects, we're thinking, especially as scientists, we're thinking, how do we get this thing done? How do we accomplish this goal? How do we make a thing that does this? But with a project that's so big, it's almost, it makes me think more like less like a task and more like, or like a recipe and more like a community garden. In that, you know, these things have to be maintained and they have to be like put together in a way where someone can walk up and figure out what to do, especially because of the longevity requirements on these projects. And it's interesting being very well acquainted with like the DM developer guide. At first I was like, oh my God, I have to do all this stuff to make this thing work. And now I'm just so grateful that I do those things all the time, because it means that I can walk up to anyone's code, read what it does, like, and just kind of jump in. And I know that if I'm sick for a week, someone else can take over for me. And, you know, it takes care, but it feels a lot more like watering my plants. So I think I'm concerned looking at the science community, because unlike DM, they don't have such a sort of unified effort and set of tasks. And what I want for the science community is to be able to look up and feel like they've watered their plants. But I don't know how that coordination is going to happen.
I love the garden analogies, and I really appreciate how you got around the requirement of one concern, telling us what was your most concerning aspect and what it is now. Very nice done. So the other thing I wanted to do is, so we heard person power, expertise, communication, data volume, style guide, duplication of effort, and treating software like a community garden. I wonder if the audience has concerns that are not part of this set, that our panel has not raised, and if they want to spell them out, and then we get our panel to comment on them. Oh, thank you.
So it was touched upon briefly. I can't remember if it was yours or Heather's talk, but the idea of, I think it was Heather's actually, recognition of the effort. So this idea of you have GitHub, it has, it will log whose commits are what, and you can get your effort there. But then we are in astronomy. Publication is to some level how we get the credit for our work. So that's one of my major concerns. And I guess just to slightly answer my own the suggestion, just to plug JOS, the Journal of Open Source Software, as a solution to this. I've done some reviews for them. It's very good. It's very easy to do, both on the review side as people who are experts, but also to submit to. And you can combine it with your science paper. So you submit to the AAS and you get a joint publication of your science paper, and your code base then is citable. And if everybody puts their things on JOS and then everybody cites everybody's things on JOS, that goes a long way to just, as we've talked about in the comments on this, how do you get the funding agencies to recognize this? If this just becomes what happens, then they have to adapt. We can sort of force them to do that. And JOS, I think, is one of the ways forward.
Yes, thank you, panelists.
An additional possible source for citable software is ADAS, because you can go, you make a presentation, then you write a 1 or 2 page conference summary that actually is reviewed and published and cited, and that's how I do it.
Any of the other panelists want to comment on this?
Yeah, I support publishing papers, like even like in some open journals or something with your software code with a short description and like pointing towards you. I will cite it if I'm gonna use it. I do that. Please do that. Also, please, like in the GitHub repository, point towards like where to look for this information. It's sometimes hidden.
Yeah, that's a really good point. Your README should have like the big tech that has to be cited, because other makes it so much easier. Marina, please. Yes. Just unmute when you want to jump in, Marina.
Yeah, thank you very much. I'm so sorry. I didn't realize that I'm muted. So yeah, I just want to have that. I just want to say that I had one more concerns, especially with the publishing with the software paper, because they're really different from the astronomy paper that we are used to publishing. And currently, we are actually writing such paper. And I have to say that this is the one more thing that we really need to learn from the beginning, how to explain our software in a language that software developer actually use. So this is one more thing for us to learn.
Thank you, Marina. Azali, you have another comment? Another concern?
Yeah, I think a concern that I have is I think it's often feels easier for us to write our own tool than learn someone else's tool, especially if there isn't support. Like we have software that is like used by my group, and we have a whole channel devoted to people asking the person who wrote it questions. And I don't know if people would be using it without that person then responding to everything. And I think I see this happening with spectroscopic data reduction tools where everyone has built their own for their own telescope. And I see, like the number of photometric reduction packages that are published as papers and put out there, but there's not, even with AstroPy backing photutils, there still isn't that everyone's kind of building their own. And so I think a big concern I have is either like how do we provide that support so that something can take traction in the field, and not just kind of always do our own because it feels easier than trying to read someone else's code and figure out what they were thinking and how to modify it to exactly what we're thinking.
Any of the panelists wants to comment on that? I was talking about it with Alex once yesterday. We were just saying how sometimes it's easier to reinvent. It's faster to reinvent the wheel. It shouldn't be the case. There's 2 hands up. I want to acknowledge that it is 30 past. So if anybody wants to leave, please don't feel bad. But I would like to allow these two questions, Sid and then Michael.
Okay, thank you. I just want to echo Azali's point. And I think when designing software, one thing that's important to keep in mind is that I've seen that there's a tendency that you want to abstract everything away into a package, and which makes the package really easy to use. But oftentimes, like the package itself has defaults, which might not be really needed for someone else using the package. So I think one thing you should try to keep in mind is to abstract away the things that might be really used by everyone else, and everything else, even if it's just 3 lines extra of copy paste, but having that ability to edit might give more people like the opportunity to actually use the package and edit that. So thank you.
Thank you, Sid. Any other panelists? Any other comments on this? If not, Michael?
I'll admit this is a comment, it's not a question. If you are a graduate student or advising a graduate student and your desire is to get a PhD in astronomy, astrophysics, physics, to go on to do science, then you need to demonstrate that you are doing science. Developing a tool that you're going to use to do that is great and awesome. That tool existing in an ecosystem where it lives on and be supported is important. But that's not your degree. And it's important to be clear about that if you're a student, and particularly as an advisor, and that part of the puzzle needs to fit into this. And it is totally natural to want to write your own. That is the understanding the problem phase. That's the prototyping phase. And then the horrifically difficult thing to do is then throw that out, and now you understand the library and package that someone else did, and go do that. And how do we get that part to work, where the prototype to final product stage is just like if I teach a numerical recipes class. Okay, here's how to write a Rangakuta integrator. Now, please never
Half of
use
this
that.
audience doesn't know what numerical recipes is. Remember that.
I'm sorry. Thank you. You're making me feel old. Anyway, the key point was, how does this
Not
fit
true.
into the
Do my students
career?
know what numerical recipes is? There you go.
I'll just summarize the
Please
point
carry
being
on.
that how does this fit into the career of the people writing a lot of this? And to remember that we are not training software engineers, we're training scientists who know how to use a key tool that is part of their analysis.
Thank you, Michael. Very sadly, this is all the time that we have. Thank you, wonderful panelists, for sharing your time and your expertise with us. Can we give them a round of applause? Thanks, everyone. Sorry for keeping you a
Thank
little
you
bit
very
later.
much.
And please, if you wish, keep the conversation live on Slack, on the Slack channel. And panelists, please keep an eye on the Slack channel. Keep an eye on the Slack channel. There might be more comments coming in later. Thank you, Marina, for joining us remotely.
Thank you very much. Bye-bye.
And thanks you if you're still there. Thank you, Heather and Alex, for your remote talks.